Thank you for joining us. In today's session, we'd like to understand how to create a simple Scratch game. First, we'll run the Scratch application. Our intention is to create a simple game that allows a user to avoid the falling objects. To do that, we'll start by choosing a backdrop. The backdrop we'll select is in a night city. Okay, so the next thing for us is to also select a sprite. In our case, we have different sprites. The sprite we wish to add is done. Our intention is to see done avoid any falling object. To achieve movement, we'll be using the left and the right arrow keys. Done is our sprite. We can reduce done size to 20. We can increase it to 50 and let's see the size. Yeah, 50 looks good. Now, to ensure that done is able to move to the right and left using our arrow keys, we will use control block. And the control block of our choice is if then. If then. The reason is we are going to provide a condition, and the condition is when a key is pressed. We'll go to the sensing block because it will be checking if certain inputs are provided, and this time the key press. The option we have for that is key space pressed. The best thing is that we have an option to select a specific key. So we've added the key space pressed. Let's change, instead of space key, we change it to the right arrow key. We'll duplicate this, but this time change it to the left arrow key. Move 10 steps. The positive number here denotes a positive direction. We'll also do the same, bring it down here, but change it to -10 because we like the left key pressing to result in a left-hand direction motion. So if achieved this, what we just need now to do is to ensure that these two are done indefinitely. We'll go back to control block, choose forever block, and have everything included inside the forever block so that done is able to move to the right and left indefinitely. We'll add under events block when the green flag is clicked so that every time we have our green flag clicked, we'll be able to see our program running. Okay, so I've clicked to activate, and let's try and see. Pressing left and right, we're able to move down from left and right to avoid the falling object. And which is this sprite that we can consider as an ideal sprite for this context. We have a ball, we have a balloon. Let's try lightning. During thunderstorms, heavy rains, lightning strikes, and whenever it strikes, we are expected to be indoors for safety. Okay, so we've been able to add the second sprite, and the second sprite is the lightning. We can also reduce the size a little to 50 or make it slightly larger to 70. Okay, so we have our lightning sprite. Just like we did in the previous sessions, we can also change the costume. You can change the costume to color red, lightning. Okay. Dan has found himself in a situation where it's raining and there's need to rush home or look for a place where he can shade himself to avoid the lightning strike. So anytime you're moving from up down, you're looking at the y-axis. You're looking at the y-axis. Every time you're moving from left right, you're looking at the x-axis. So our intention is to have this lightning move from up down. To achieve that, we'll use the motion, and the motion this time is changing y. So we'll drag change y position. So every time you have this, every time I want to click on change y, positive number moves the lightning upwards. A negative number moves the lightning downwards. So you can see. So our intention now is to see how Dan will avoid the lightning. The threading of lightning normally as well starts at any position. So what we'll do is go to random position. Random position will allow the lightning to fall from a random position. Let's see. So it goes to a random position, and as well it can change the direction to fall from up downwards. To initialize the position of the lightning, we'll need a control structure. We'll need the if then logic. Therefore, we'll need to know the position. Is it there? Yes, it is here. It is here, y position. But before we actually know, we'll need the operators. The operators allow us to test a relationship. For example, if y position, so we like to test the position. Whenever you see a positive number, for example, we drag and move this lightning up, you'll notice here we have a positive number. When you move this down here, you'll notice you have a negative number. So we like to know, where is the y position? Where is the y position? We'll use the less than symbol. So we like to test the condition. If y position is less than, if y position is less than, for example, negative 170. Why 170? When you bring the lightning symbol down here, that's 117. I bring it further down, 176. We bring it somewhere here, that is negative 120. So we can change it to at least negative 120. Let's see, negative 120. We like to know, is y position at around negative 120? If it's around negative 120, then we need to force the lightning to go up to a random position. Once it's up there, go to a random position, then we keep changing now value of y by negative 10. So once it has gone to a random position, we like to change the value of y. But this time, we don't want to change it to a negative value. We like it to go all the way up. So let's test. When we move this lightning up, what's the value? Positive 123. So we can change it to a positive number, 123. The intention is to make sure that when this lightning comes all the way down, after reaching down here, it has to go all the way up to a random position. So it can start here, it can start here, it can start at any random position here and repeat the same thing. So we'll move the whole of this into the if criteria. To sustain this, we'll have it inside a forever. Let's do this indefinitely. So we'll bring this in and have it inside forever block. We're just defining the upper limit and in a way the lower limit at any random position. To provide the change, then we'll need to introduce a change of y. We need to change y position. Change y, it's here. We have this. Change y position. The default value is 10. If you want to make sure that this is falling downwards, so we'll change it to a value like -5. Okay, then attach it. Yeah. Inside, we have it inside forever block. Then as usual as well, we bring in the when green flag is clicked. Okay, so let's see if our idea is working. The sprite has done a reset, but let's just try and see. Clicking on it, you'll see lightning falling. Click on the sprite, change the size to, instead of 320, maybe to 70, let's see, or slightly larger, maybe 80. So we have, based on this activity, you'll notice now we have two programs. Click on start. It's falling. Dan is avoiding, trying to avoid the lightning. What we like to do now is we like to warn Dan. We like to warn Dan never to play whenever there are rains and thunderstorms. To achieve that, we'll click on variables. We like to do this, and every time he is struck, we provide warning attempts. To achieve that, so we'll create a new variable. We refer to it as warning. Apply this for all the sprites. Here we have the warning, and this variable will be keeping track of instances where done program is complete, because our intention is just to see. To program the lightning, we'll select the lightning sprite and then add more controls. So we will bring in if, like in the previous case, because we like to test a condition, and sensing, because we want to listen to the keyboard and see is someone pressing the left or the right mouse button. What we'll do is drag in this touching mouse pointer. We'll take it inside because we like to know whether done has been touched. Touching done? Yes. So what happens when you touch done? Motion. We can have the movement to go to a random position. Then we can change y as usual. In the previous case, we can change y by, because when you move this up by around 170, because we like to initialize the sprite, the lightning, to go all the way up a random position. So go to a random position, then change y by 170. It will go all the way up. When done is touched, then do this. We'll go to events block, bring in that flag, and we click on it. It's being executed once, so that means we need to bring in a control that sustains this forever block. So we'll bring in forever block and have this, so that the next time you click, the program becomes live and you can interact with it. The same thing. So now when you combine the lightning falling and then trying to avoid, we've noticed it's a little larger. We can reduce it to 60. Then initialize. Therefore, you've noticed touching touching down means one sprite touching another sprite. When you click again on the green flag, so I can be able to move the two. This one is moving, the other one is moving. So it's avoiding striking by the lightning. We added a variable called warning. So how do we count the number of warnings done as received? What we'll need to do is for every touch, then we provide a warning. And where is the warning? Is it in events? We like to see the option that allows the application to change its behavior. We go to controls, look at this, change my variable, but this time because the variable is warning, change it by 1. So if initially it was 0, now it will be incrementing the value for every touch. Therefore, we'll just bring it into the control structure and have it somewhere here, even before going to a random position. Take note, are you seeing the number warnings? So we've written a program for done, and we've also written the program for lightning, the two activities. Next, we like to play some sound. When you go to sound block, whenever there is thunder and lightning, we need to hear some sounds. How do we achieve that? We need to play some sounds. But before as well we do that, we need to explore and see which are these sounds available to us. We added a sound and then listen. So we can choose dance snare. Then you go back to our code and you will notice now dance snare is appearing here. Play dance snare beat. Click on the option and choose dance snare. And bring it in. Want this to be repeated forever, so we will choose control forever, so that every time you're playing the game, you're able to hear some sounds. To activate together with the others, we will add the block when the green flag is clicked. So whenever you have the green flag clicked, you will continuously hear some sounds. Stop, play again. Okay, so that's a computer game with some music behind the scenes. What if during the touch, when the lightning strikes the character, we also have some sounds? We do the same thing. We go to sounds, click on start, and then identify a sound of our choice. So just trying to test which sound is best suited to the environment. Okay, so you can choose this bonk sound because it's not very pleasant. Then we go back to the code. Whenever there's a touch, what should happen? We play the music as well as play some sounds, short sounds. So we'll go to sound, and then because we'd already selected bonk, we'll just select bonk. And where do we place it? We can have it inside the if. After touching, done, you'll be able to hear some sounds to show that something has happened. Okay, we can trigger. Let's listen. Notice anytime you hear, anytime there's a touch, you get to hear a sound. Still seeing lightning a little bigger. You can remove it by reducing to 60. So every time the lightning strikes, done, you're able to count as warnings, as different warnings. Okay, so it's an interesting game. Thank you so much. We'll meet in the next session.